So today's webinar is entitled Climate Change in a Land of Extremes, Earth Systems and Climate Change Hub 2015 to 2021. This is the final webinar for the Earth Systems and Climate Change Hub, which finishes on the 30th of June, so just next week. So I'd like to begin the webinar though by acknowledging on behalf of the Earth Systems and Climate Change Hub, the traditional owners on the lands and seas that we all live and work upon across Australia, and pay our respects to their elders past, present and emerging. We honour and celebrate the spiritual, cultural and customary connections of traditional owners to country and its surrounding seas and oceans. Our presenter today is Professor David Karoly. David has been Hub Leader of the Earth Systems and Climate Change Hub since early 2018. Also helping us on the webinar today, I'd like to introduce Sophie Schmidt. Sophie is a Communication Officer for the Hub and for CSIRO. If you have any technical issues or questions or feedback, please flick Sophie a message in the chat function and she'll be able to help out and answer any questions that you have. I'd also like to acknowledge Mandy Hopkins, who's Knowledge Broker and Program Manager of the Earth Systems and Climate Change Hub. Mandy was meant to be co-presenting the webinar today with David, but unfortunately can't be here today due to family emergency. But I think, look, let's get stuck into it. I'll hand over to you, David, to begin the webinar. Thank you.
Thank you very much, Sonia, and thank you very much for this introduction. As you will, I hope, all be able to see, I'm already sharing my screen, and it's both an honour and a privilege to be able to have been the Hub Leader for the last 3.5 years. And what I'm going to do today is essentially give a summary of some of the research highlights and the engagement activities that the Hub's been involved in over the last 6 years. But to start off with, I'm going to start perhaps right at the beginning of the Hub. And the first thing I have to do is to make sure that my slides are progressing. That's fine now. The Hub is in fact part of the National Environmental Science Program funded by the Australian government. And the government offered the opportunity of funding through the NESP program, as I'll be calling it, way back in 2014. And I was in fact originally involved as a chief investigator in the application in 2014 that was led by CSIRO, and the application by the Earth Systems Hub, as it was originally called, was successful, announced at the end of 2014, and it's a partnership between CSIRO, the Bureau of Meteorology, and 5 different university partners, specifically focusing on improving the understanding of climate variability and climate change, with an emphasis on the science and an emphasis on the engagement. But it's important to also remember that the National Environmental Science Program, the Earth Systems and Climate Change Hub, is one of 6 hubs, and its name was originally, as I mentioned, the Earth Systems Hub, but it was changed thanks to the initiative of the Minister for the Environment at the time, Greg Hunt, who decided that it was critically important to include the words climate change in the name of the hub way back in 2015 when it was announced. So look, the hub has always had an emphasis or a focus on trying to provide climate change information and climate science information to ensure that Australia's policies and management decisions across our whole range of different stakeholders were informed by the best available science over the life of the hub, but also for climate change science implications for the future as well. And what we're going to do here is talk about, if you like, the foundations of the hub, what it's carried out over its life over the last 6 years, and some of the highlights, both in terms of research and engagement. So the emphasis, as I've said already, was to ensure that the science information was provided to a wide group of stakeholders to ensure that the science, particularly information on both climate variability and climate change was well understood. The emphasis then was on providing information that was accessible and usable by stakeholders to allow them to effectively manage their decisions. And it's also critically important to understand that the engagement with initially the Department of Environment and now the Department of Agriculture, Water and Environment has given direct access of the Earth Systems and Climate Change Hub researchers and knowledge brokers to providing information in policy areas, particularly around climate adaptation, impacts in World Heritage areas. And the hub identified a set of what we called targeted user groups that included the federal government, state governments and local governments across all those governmental sectors, included if you like, the government managed authorities like the World Heritage areas and other aspects as well. The water resource sectors managed at state and at federal levels, as well as areas that are critically important in, if you like, the climate change mitigation areas in managing information about carbon accounting and greenhouse gas emissions monitoring, as well as opportunities for climate change mitigation through blue carbon. And I'm going to cover many of those different areas. But one of the key impact areas, and if you like, stakeholder groups that we have involved with, has been Indigenous stakeholders. And the hub was always actively involved with Indigenous stakeholders right from 2015 and 2016, has developed trusted relationships with Indigenous communities and Indigenous stakeholders through two-way conversations, trying to understand the needs of Indigenous stakeholders as well as seeking to provide information that's relevant, directly relevant to Indigenous stakeholders. And finally, what we need to understand is that the hub's involvement in NESP was critically important in effectively providing connections to the other environmental areas covered in the National Environmental Science Program. Things like marine biodiversity, threatened species recovery, and livable cities are all some of the areas covered in other NESP hubs. So, research achievements. I'm going to focus now on a number of the different research themes that the hub has been involved with. We know that there are important variations in climate extremes that have affected Australia over the last, well, probably last 50 years. I'm going to cover a range of these thematic areas that have been identified and then synthesize these and essentially only pick out a number of the highlights in the range of these different thematic areas: climate extremes, climate variability, coasts and ocean, carbon budgets, and particularly some of the underpinning support areas like the climate model development. In addition to the sort of research achievements, I'm also going to focus on the aspects covered under our major user and stakeholder engagement activities. And as I've mentioned, Indigenous science has been critically important in, if you like, our communication and emphasis amongst stakeholders. But I'm also going to talk more widely about some of the achievements in providing climate science information to stakeholders in the finance sector, stakeholders in agriculture, stakeholders in water resources, and in the World Heritage areas. And the way that the hub has effectively co-designed our engagements with stakeholders to ensure that we listen to our stakeholders and what their needs are. So I'm going to cover a whole range of stakeholder engagement areas as well as the science areas. Let me start off now by looking at climate extremes. And obviously the 2019-2020 Black Summer extremes, both bushfires and heavy rainfall in 2020 has emphasized the importance of both climate variability and climate change in changes in extreme events. And I'm going to cover some examples, not only bushfires, but a range of different examples. I can really only touch on the highlights, but it's critically important that the climate extremes is where there are the most important impacts on ecosystems, on business, on infrastructure, and on people, on communities around Australia. And so in some sense, understanding climate adaptation really requires information on climate extremes. So what I'm going to do is touch on some of those examples and case studies. And unfortunately, I'm going to start with one of the most dramatic examples, and that is bushfires. Bushfires has always been one of the focuses of the Climate Extremes project within the Earth Systems and Climate Change Hub. And what we've seen is that there has been major increases in the sorts of fire weather conditions, usually measured in terms of a range of, if you like, measures like the Forest Fire Danger Index over the last 70 years, with dramatic increases in bushfire conditions, essentially due to climate change. And critically important, before the Black Summer extreme fire danger conditions, the Hub had released earlier in 2019 its report, 4-page summary report on bushfires and climate change in Australia that was provided to the Australasian Fire Authorities Council to provide advance information on the latest understanding on climate change and bushfires. So this was a critically important, if you like, not warning of the bushfires that were coming up, that came more about the seasonal fire reports from the seasonal fire outlooks from the Bureau of Meteorology, but it was really emphasizing that these climate change is increasing the risk of fires, increasing and changing the seasonality of bushfires. And the information is, yes, not only have bushfires got worse and more extreme fire weather conditions over the last 70 years, but they're projected to get significantly worse, not only over the next 40 years, but continuing through the rest of this century, dependent to some extent over how much the climate continues to warm in Australia and around the world. But independent of human-related emissions, we know that the bushfire conditions are going to get significantly worse over the next 40 years and longer. What we also know is that many of these extreme bushfires have led to fire-generated thunderstorms, usually called with the sort of jargony term pyrocumulonimbus, but essentially thunderstorms associated with the extreme fires. There's been a substantial increase in those over the last 20 years, and projected further increases. And those thunderstorms can lead to, if you like, fire-generated extreme conditions and lead to rapid spreading of fires because of the large scale. And so the Black Summer fires were the worst examples of these fire-generated thunderstorms that we've seen in Australia. Unfortunately, we expect, as I said, continued increases in fire danger, as well as changes in the fire season, with worsening conditions in South and Eastern Australia, particularly in springtime. Now, another major climate extreme, we hear about heat waves and they're conducive to extreme fire danger conditions, but heat waves in the coastal areas, marine heat waves, also have major impacts. And in particular, we've heard about marine heat waves affecting the Great Barrier Reef. But research within the Earth Systems and Climate Change Hub has contributed to improved understanding of marine heat waves, particularly recent examples in the West Australian coastline and affecting Tasmania, And we know that we've had an observed increased frequency of marine heat waves, as well as projected ongoing increases in the frequency and intensity of marine heat waves. We know that they have major impact on marine ecosystems, natural systems, as well as aquaculture systems as well. Now, other sorts of extremes. Look, I'm going to talk about increases in tropical cyclones because they have major impacts across northern Australia. And to some extent, there is a little bit of good news, and that is that the observed frequency of tropical cyclones, the total numbers of tropical cyclones, have declined over the last 30 years of high quality observations from satellite data, and they're projected to decline further in the future. The only problem with the declining frequency is actually the numbers of the most intense tropical cyclones, and the amounts of rainfall associated with the tropical cyclones is projected to increase. So reductions in number, but unfortunately increases in the heavy rainfall associated with the most intense tropical cyclones. The Hub has prepared a web-based tool that allows to provide information on tropical cyclones and their tracks, both at present in the observations as well as projections into the future. And that web-based tool is readily available through the Hub's website. Other sorts of intense, if you like, ocean-related storms are east coast lows that affect the east coast of Australia as low pressure systems. They have rather different circulation dynamics, but have some of the similar characteristics. They particularly affect heavy rainfall on the mountain and coastlines on the east coast of Australia, from Gippsland in Victoria up to southern Queensland. And what we find is that although the circulation dynamics are somewhat different, the sorts of climate change projections indicate many of the same sorts of impacts of climate change on East Coast lows, which is reductions in the total numbers, but actually increases in rainfall, at least associated with the fact that a warming climate is associated with more moisture content over the oceans. And therefore, when we have intense East Coast lows, they're leading to more intense rainfall and heavier rainfall. We've seen that in a number of the intense rainfall events along the east coast of Australia over the last decade or so. Now, the Hub hasn't only focused on intense rainfall events, we've also focused on rainfall extremes at the dry end. And the Hub has produced updated drought projections that are critically important for water resource managers and for agriculture. And the evidence is that we're likely to see increases in the time that's spent in drought. Recognize also that there will be substantial climate variability in many parts of Australia. And so the longer and more intense droughts will likely be interspersed by substantial climate variability with wetter periods. But we also know that in parts of the southwest of Western Australia, South Australia and Victoria, through much of southern and eastern Australia, there have been prolonged dry periods, reductions in rainfall in southern and southwestern Australia and southeastern Australia, particularly in wintertime, and this has major agricultural impacts. Another agricultural impact is associated with something called flash droughts, and that might be perceived to be a jargon term. It's not a new type of drought, but the Hub's been heavily involved in understanding the causes of these flash droughts, which is declines in rainfall that happen associated with the warmer temperatures leading to, in dry conditions, increases in rainfall, rapid loss of soil moisture that has major impact on agriculture. And I should be monitoring my time progress to make sure that I don't spend too much time just on one case. So what I'm going to do now is talk about some of the critically important factors associated with this year-to-year variability in climate, the so-called climate variations. We've known about climate variability, and as one of my favorite climate experts like Alan Jones will tell me, we've known about climate variations from the Dorothea McKellar poem, Australia is a land of droughts and flooding rains, but we also know it's also a land of heat waves and bushfires as well for more than 100 years. And they're absolutely right. Climate variability is critically important for the large rainfall and climate variations across Australia. But now we also know that climate change is impacting those climate variations, and climate variations are superimposed on longer term climate change. And it's understanding the link between climate variability and climate extremes that's critically important in our understanding of changes in risk and resilience and how that's affected by climate change now, over the last 2 decades, and into the future. What we do know is that many of these climate variations are driven by ocean variability, things like El Nino, warm events in the tropical Pacific Ocean, and La Nina, cooler events in the central tropical Pacific, and their impact on rainfall, as well as the Indian Ocean dipole, and all of those lead to major climate variations. And it was an event associated with the Indian Ocean dipole that was critically important with the black summer dry extremes over much of eastern Australia. So now it's critically important in understanding ocean variability to have high quality ocean monitoring data sets. And what's shown on the right-hand side here is a sort of graphical view of the many different sorts of global ocean observing systems. Now, the hub hasn't been involved in specifically new observations over the ocean. There are CSIRO, marine, Oceans and Atmosphere has been heavily involved in supporting ocean observations, as well as the International Marine and Ocean Observing Systems. But what the hub has been doing is improving the quality assessment of Southern Ocean and global ocean observing systems. And these improved ocean data sets are then used to provide global assessments, international assessments of the role of climate variability and climate change in changes in the ocean, including long-term increases in the heat content of the oceans, as well as long-term observations of changes in the carbon content, and even in changes in the salinity in the oceans, all of which are critically important in understanding the links between changes in the atmosphere and changes in the ocean and the ocean drivers of climate variations. Now, of course, there are multiple different aspects of the ocean variations, and a large fraction of the Australian population lives very close to the coastline. All of our major cities, except Canberra, are on the coastline. A large fraction of our population lives very close to the coastline, and that means that the coast is already affected by sea level rise, and the hub has been involved in updating sea level rise projections to show that increases in sea level rise are being more affected by release of fresh water from melting of the Antarctic ice sheets. And the sea level rise projections have shown an increase in the projections, and that then leads to increases in sea level extreme events. And much of the impact of sea level rise is not from the mean changes in sea level, it's associated with the extreme sea level events. And the hub's been involved in releasing a new web-based tool providing information on sea level extremes in many different regions, or in fact all around the Australian coastline, both on the open coastline and also in protected harbours. And in particular, the research both on the sea level rise, the mean projections, and on the extremes has been critically important in understanding the rapid increases in sea level extreme events that we've seen, leading to major erosion events, usually associated with storms, but also with changes in long-term, if you like, wave climates associated with changes in average wind conditions as well as in storm events. And it's critically important to understand that some of the areas, if you like, the historical sea level extreme events, the so-called 1 in 100 year extreme event, has been becoming much more frequent. And in fact, for projections for the end of the current century, in many parts of the Australian coastline, what used to be 1 in 100 year events will become once every year event in many parts of the Australian coastline. And so coastal defences and planning for these coastal extremes becomes critically important. And on the right-hand side, I'm going to now talk about a slightly different approach for managing coastal extremes and managing coastal coastlines, and that is through the National Centre for Coasts and Climate, which was established in 2014 at the University of Melbourne, and then has been supported over the last 6 years as a major research activity through the NESP hub. And it's focused on 3, if you like, important different areas in monitoring and managing coastal erosion, particularly monitoring first of all, and then managing coastal erosion through nature-based methods for limiting coastal erosion. And then finally, through looking at what is called blue carbon, through natural ecosystems and the uptake of carbon dioxide through these carbon natural systems, and then the storage of carbon through the uptake of carbon dioxide through vegetation system and in sediments in coastal ecosystems. So the National Centre for Coasts and Climate has been critically important in leading these sort of what are called blue carbon approaches, as well as in managing nature-based solutions in ecosystems. The blue carbon is part of, if you like, understanding the important different uptake of carbon dioxide and understanding the carbon dioxide uptake in the ocean systems as well as in terrestrial ecosystems is part of understanding the global and regional carbon budgets, which has been another major research project area within the hub. I've been heavily involved in a research project on global and regional carbon budgets and has been providing leadership of the Global Carbon Project, which is an international project that provides annual updates on monitoring of the, if you like, the different sources and sinks of carbon dioxide, as well as sources and sinks of methane and nitrous oxide, the most important greenhouse gases associated with human activity. And what these updates have been doing is allowing countries, including Australia, but all around the world, to update their sources and sinks to understand this. And one of the important aspects was to be able to monitor the impact of the COVID-19 virus and the cutbacks in industrial activity as well as transport, what they had in terms of reductions in carbon dioxide emissions. And there was in 2020 more than a 7% reduction in carbon dioxide emissions from industrial activity, from transport in 2020. The important thing to bear in mind is that is the largest reduction in greenhouse gas emissions, substantially larger than even in the global financial crisis. But even such a large reduction, 7% reduction in carbon dioxide emissions, did not lead to a reduction in the concentrations of carbon dioxide in the atmosphere. But it is the concentrations of carbon dioxide, not the emissions, but the concentrations of carbon dioxide. And they've been growing every year and continue to grow in 2020 and are expected to continue to grow until the globe reaches net zero emissions and even beyond that. So unfortunately, we can expect continued growth of carbon dioxide concentrations while we have ongoing net anthropogenic emissions of greenhouse gases. The only way that the carbon dioxide concentrations will stabilize is when the globe reaches net zero emissions, and that's why we need to accelerate the reductions in emissions. But there are many different opportunities like reductions in to reduce emissions through natural processes. And I'm going to focus now on the blue carbon opportunities. And this graphic tries to illustrate that the way that coastal mangroves take up carbon dioxide through their leaves, through photosynthesis, taking up carbon dioxide from the atmosphere, storing it in the leaves, storing it in the trunks, storing it in the root systems, and in dead plant material that gets stored in the sediments in marine coastal systems, in mangrove ecosystems. Now, we also know that carbon dioxide is released back into the atmosphere. And so there's an ongoing exchange of carbon dioxide between the plants and the atmosphere and between the ocean and the atmosphere in much the same way that land-based ecosystems will take up carbon dioxide through vegetation, but will lose carbon dioxide from the soils, and there's opportunities to store carbon in the soils in much way that carbon dioxide can be stored in marine sediments. It's the balance, and we need to make sure that we end up with net zero emissions as well as ongoing increased storage. So what about some of the underpinning infrastructure? What we know is that the hub has been heavily involved in the development of the latest coupled ocean atmosphere climate model through collaboration with CSIRO, University and Bureau of Meteorology scientists. And this latest model has been fed into what's called the sixth phase of the coupled model into comparison project, together with more than 60 different new generation coupled models. And these coupled models are then analysed by scientists all around the world and fed into international science assessments of climate change, as well as being used in Australia. And what we've found is that in terms of the magnitude of the scale of, if you like, the access model simulations, there have been more than 9.5 million data sets downloaded from the international CMIP6 archive just of the access coupled model, and more than 14.5 million downloads of a new CSIRO coupled Earth system model together with oceans and atmosphere. This is the first time that CSIRO has made a contribution of the Earth system model, and the hub has managed a lot of the uploads of that data and the quality control of that data to go into the CMIP6 project. Now, I need to speed up a little bit more. We also know that within the hub's research, there's been improvements in the model performance for the next generation, as well as opportunities to essentially use the access model simulations and the CMIP6 model simulations to understand climate variability in Australia. And this graphic on the left-hand side compares the current generation of CMIP6 climate model projections across the whole set of CMIP6 models, or at the set available about the beginning of this calendar year, together with the earlier generation CMIP5 for high emissions and low emissions. What we see with the black line is the observations. And what we see is that both sets of models span very well the observed year-to-year and decade-to-decade variability and the warming of Australian average temperatures over the 20th century. What we see is that there's continued warming projected by at least another degree, even relative to present day temperatures, and even as much as 2 degrees in some of the greater warming scenarios. But if we look at higher emissions, the new CMIP6 models show substantially higher range of warming for high emissions scenarios. They indicate if you like, a larger spread across the models, but also substantially greater warming. Now, in practice, the global models do not provide adequate resolution of information to look at many extremes. We need to look at higher resolution information. I can see I'm going to have to speed up a little bit to allow some time, but we know that we've got to look at regional climate models. And these regional climate models, what this graphic shows in the Australian region is the added value, and the darker coloured regions are regions where there's improved value in using higher resolution climate model simulation compared with the global models. And what we see is that the most improved information is in the coastal areas in northern Australia and in Tasmania, which regions of high topography, and in coastal regions, and in regions of tropical weather systems. And all of those demonstrate that we can gain information using higher resolution simulations. So what's next? Well, I'm now going to shift from the emphasis on the science and the information, the achievements in the science, to some of our stakeholder engagements. And it's particularly important to focus on the way that the hub was engaging with our users, was to meet with them, to develop trusted relationships over time, to find out what their needs were, and to co-design their projects around adaptation or climate needs with scientists and with the users. Not for us to sort of top down tell them what we think they need, but to work with them, not only in the Indigenous science area, which I'm going to talk about, but a range of different climate information and climate capability areas. So I'm going to start in the Indigenous science area, and I've talked about it a little bit before, but I want to start off by saying that the Indigenous knowledge is critically important for helping Western scientists, climate researchers within the hub, to better understand the changes that the First Nations peoples have experienced from the last ice age to the current period. They're the only continuous Indigenous population to have managed ocean country and land country sustainably through the magnitudes of changes from the ice ages to the current interglacial period. That magnitude is now happening much faster than it did in the ice age to interglacial transition. We need to use Western science or modern science to help First Nations people to look at managing the health of country, but we can learn from their historical experiences, from their stories over time. We have worked with Indigenous communities over time, and I'm going to talk about some examples. We had 2 major national dialogues, the first one in 2018 and the most recent one in 2021, that brought First Nations peoples and communities, traditional owners from different communities from all across Australia. In particularly earlier this year, we had more than 100 traditional owners working with 10 climate scientists from across the hub in better understanding and engaging and taking information back to the traditional owner communities across Australia to better understand the health of country, which they are already seeing is changing. And if we look at a couple of specific examples where we're seeing changes associated with climate change in country, the first example I'm going to talk about is in Western Australia on Shark Bay, where the traditional owners noticed major loss of seagrasses. They weren't clear of the information, and the traditional owners worked with scientists from the hub as well as scientists from Western Australia to better understand the role of marine heat waves and in sea level rise in impacting the marine and coastal ecosystems around Shark Bay. And separately, another more recent event has been the hubs working with the World Heritage Area on Karoly or Fraser Island in better understanding the bushfires that occurred in 2020, not just in 2019, but the second set of bushfires in Karoly in 2020, and the fact that the traditional fire management knowledge wasn't being used, and how the climate risks are changing because of climate change, but traditional fire management knowledge could help in managing fire in the World Heritage Area. Let me move on from Indigenous science to some of the other impact areas. And I'm going to pick a couple of case studies first. I'm going to concentrate on the mango industry in the Northern Territory. We got contacted by the Department of Primary Industries and mango farmers who were noticing reductions in their mango fruiting and the productivity of their mango farms. And they were asking for information. We worked with the farmers, the primary industry, and what they helped us to understand better was the sorts of factors like the criteria for mango flowering and for mango fruiting was dependent upon cool temperature extremes in the cooler season in the Northern Territory, as well as not occurrence of high maximum temperatures. They need cool temperatures to produce flowering in the cooler season, but they then need to avoid the higher maximum temperatures at the end of the dry season. And unfortunately, the cool temperatures that are required for mango flowering are dropping, and the high maximum temperature increasing, and that both of those lead to reductions in fruit production. And the hub worked closely with the farmers and the Northern Territory primary industry to look at the sorts of approaches that might be able to be used in managing those ongoing reductions in, if you like, fruit production through adaptation. Another example of the, if you like, working with, industry was a really interesting project on the management of Gondwana rainforests in the World Heritage Area along the New South Wales, if you like, topography areas from New South Wales and also in southern Queensland, which had been experiencing losses and declines in moisture content. And the scientists' assumption was that the decline in rainfall was primarily associated, the decline in moisture content was associated with changes in the rainfall patterns. And yes, there are large impacts, such as in late 2019, associated with declines in rainfall. But when we started to work with the managers of the Gondwana rainforests, they're a cloud forest, not just moisture provided by rainfall, but moisture. More than 30% of the moisture in the cool season is provided by moisture from clouds. And climate change has been leading to an increase in the elevation of the clouds. So the changes in the cloud height have been leading to a drier climate long term, and we expect that to continue. And this was, if you like, not what was expected by the scientists, but by working with the managers, we were able to better understand the, if you like, the ecosystem drivers and the changes. What I need to do is to speed up a little bit more. So where else have we been involved? We've been working with providing updated climate-related information on drought and water futures that I've talked about, sea level rise, but we've also provided updated climate change information through an update to the Climate Change in Australia website. And that Climate Change in Australia website is now providing climate change information around different warming levels, like the 1.5 and 2 degree target levels from the Paris Agreement, but also higher warming levels like 3 degrees. And so information around the impact in Australia at different warming levels in terms of temperature changes in Australia has now been provided through a partnership with the Monash Climate Change Communications Hub. And we've been getting some television coverage of these new warming level based impacts. We've also worked very closely in building climate capability with our users through what are called climate literacy workshops, where we do face-to-face interactions with climate users, and we are able to provide both the climate science information to help them understand climate variability and how they can extract climate change information from the web-based data sets like Climate Change in Australia. And that's critically important, allowing decision makers in different industries to extract the data and then inform their decisions into the future. Two specific examples that I'm just going to touch on has been the provision in the finance sector of information on climate extremes through what are called the Climate Measurement Standards Initiatives. Climate extremes information around climate provided in a standards-based approach to allow information on the impact of climate extremes on infrastructure and on buildings, to allow those risks to be better taken into account by the insurance industry. We've also provided information through the National Science Advisory Committee on climate service needs within Australia and on the next generation of climate projections. Now, all of these science informations that I've talked about have been synthesized together through a series of science fact sheets and science brochures. They're aimed at their, if you like, users and stakeholders. And those brochures are now available through the Hub website. And they're going to be information and links to those are going to be made available through the chat box now. So if you go to the chat box, you'll be able to access them. And we will be making available all those links through the Earth Systems and Climate Change Hub as well. I better finish up. Today is also the launch of our landmark synthesis report. It has much more information framed around both the latest highlights in climate extremes from the Hub, as well as our approaches to engaging with stakeholders. And the link for this 50-page landmark synthesis report is now being shared on the website as well. So what's next? Well, look, we've got less than 10 days before the Hub closes, but we're also pleased to announce that there is a new climate systems hub that starts in July. Funding has already been committed through the National Environmental Science Program. It has significantly more funding than the current hub had and has a specific emphasis in its research programs on climate change adaptation and on engagement with traditional owners. Simon Marsland is the leader of the new Climate Systems Hub in NESP, and I'm pretty sure he's online. So if you've got any really tricky questions, I'll pass them on to Simon Marsland, and he'll answer them in the new NESP Hub, because it's got 6 years to find the answers to those questions. There are also major initiatives through the new Australian Climate Service, which has been announced in the last federal budget, a partnership between the Bureau of Meteorology, CSIRO, the Australian Bureau of Statistics, and Geoscience Australia. But what I need to do now is finish up. And before I finish up, I want to acknowledge that it wouldn't have been possible to have all these successes and achievements across the hub without our critically important engagement with our partner organizations, with our researchers, but also with our stakeholders who've been very much involved in helping the hub's science be communicated to users. But I also want to thank the hub program management team, which has coordinated all the activities. And I'm only going to mention this group by name. There are many, many other people who have been critically important, but I want to particularly recognize and thank Mandy Hopkins, Marion Shepherd, Sonia Bluhm, Sophie Schmidt, Jeff Gooley, and Zarif Rahman, but also thank Karen Pierce, who was involved in the Hub program management team as a communications officer, but has moved on to other things. They are all important. Everyone has been important. And what I'd like to do now is hand back to Sonia for any questions.
Great, thanks, David. Thanks so much for that webinar and trying to squish 3 years of success and achievements into sort of 50 minutes. So you did quite well there. We have time for just a few questions. David, you mentioned some of our research being taken up into international assessments. What has been the Hub's role in providing support and information into the Intergovernmental Panel on Climate Change assessment reports?
The Hub has been involved in a wide range of, if you like, the IPCC reports, not just on the current report, which is the 6th assessment report of the IPCC, but Hub scientists from the university sector, from CSIRO and from the Bureau of Meteorology have been involved. The travel funding for those scientists is provided by the federal government, but they've been allowed time from their research activities to be involved in the meetings. And it's not just the IPCC 6th assessment report, it's also a series of special reports, including the special report on 1.5 degrees back in 2018 and 2019, the special report on oceans and cryosphere, and the special report on land and ecosystems.
Great, thanks, David. We have a question from Simon around the attribution of extremes. So Simon says that this is one area of science that has really significantly progressed in recent years. But do you think the communication of attribution of extremes and public understanding of this has progressed as quickly? Or do you still hear those comments around, you know, this is consistent with climate change, but we can't attribute an individual event to climate change?
That's a really interesting question. And I think it's a really important question because one of the ways of, if you like, testing our understanding of the science, particularly the role of climate change in changes in extreme weather events, is to apply the approach, the, if you like, new science of what's called extreme event attribution, which tries to understand the role of both natural climate variability, uses climate model simulations that only take into account natural variability, but also looks at climate model simulations and tests whether climate model simulations with increases in greenhouse gases only up to the current period are able to explain the sorts of changes in extremes we've seen. So it's a test of the climate modeling. It can then be used to communicate the fact that, yes, the climate change is already changing, that the extremes are different from what we would expect due to natural variability alone. And we need to take into account that, if you like, the historical climate over, say, the last 100 years is no longer a good guide to the climate risks, both now and into the future. And so it's critically important that when we're looking at climate risks, as will be undertaken in the new Climate Systems Hub and has been undertaken in the Hub as well, that information about climate risks needs to be based in high resolution climate model simulations, as well as what we have seen in the most recent period. the 2019-2020 climate extremes, unfortunately, become part of a normal climate in the 2040 period.
Thanks, David. And you mentioned the new Climate Systems Hub that's coming up. I thought I might just pass over to Simon to delve slightly deeper. There's been a few questions around what is next under the hub. So Simon, as the new hub leader for the Climate Systems Hub, could you just give us a very brief 1 or 2 minute summary of the aims and goals of the new hub going forward?
So the new hub will carry along with a lot of the critically important research that the previous hub has been doing. It has the same portfolio of partners, the CSIRO, the Bureau of Meteorology and the 5 universities, plus also the state's community of practice in climate science coming on board. So all states and territories coming together as a formal partner. The hub itself will run for 7 years, and it's both larger than the previous hub in its longevity and also in its funding envelope. It's also a more complex endeavour than the previous hub, I think, in terms that the 4 new NEST program hubs each house a cross-hub mission. So the Climate Systems Hub will be the home of the Climate Adaptation Mission led by Sarah Bulter. Another nice thing in the new hubs and the new NEST program is an even stronger emphasis on Indigenous engagement. So there'll be formal Indigenous facilitators associated with each hub. Ours will be Rowie Bulio. In fact, Rowie and Sarah are sitting in the room with me right now, and we're planning to get ahead of our 6 or so years to answer questions and start formulating ideas and getting them down on paper. The research projects for the new hub will spin off from 1st of July onwards. Thanks, Sonia. And thanks very much, David, for all the work that the Earth System and Climate Change Hub has done to put us in this really good position kicking off with the new hub. Really appreciated.
Thanks, Simon. So I know we are running out of time. I might just squish in one more question, David, if that's all right, because it's a fabulous question around co-design with Indigenous stakeholders. So Caitlin asks, has the hub developed any frameworks, parameters or publications around establishing co-design projects with traditional owners and what a successful collaboration looks like? Caitlin says that often traditional owners are engaged more as consultants with review of work, but not through co-design of the actual research. So could you just provide a brief comment on that, David?
Yeah, look, that's a really good question and a really important issue, and I know that it's going to be covered again and continue to be covered within the new Climate Systems Hub. But yes, the hub has developed frameworks and has actually developed a protocol for scientists to work with Indigenous communities, and that is going to be made publicly available for researchers in universities, in CSIRO, in the Bureau of Meteorology, through the new hub, as well as published in journals and things like that. It's critically important to understand that this co-design is a process of developing trusted relationships over time. It's not a case of looking at a protocol or guidelines and then saying, well, we can do this, read the guidelines and this jump in. It's a case of developing trusted relationships over time. And that's true not just for Indigenous communities, it's true with all our stakeholders and users, that the co-design takes time to understand the needs of all communities, Indigenous communities and all users. It's not a jump in, jump out again. It's a process of time.
Thanks, David. Fantastic. And I know that the Climate Systems Hub will be continuing some fantastic work on co-design with our Indigenous stakeholders. So looking forward to seeing that. So I know that we do have a few more questions, but we are well and truly out of time. So I'm sorry about that. If you have more questions for the Hub or for David, our contact information is up on the screen at the moment, that info@nestclimate inbox. Please do reach out to us. I want to thank David for a really great webinar. Again, trying to fit in 6 years of success and learnings into a 1 hour presentation is really hard. So thank you very much for that. As David mentioned, we have just released our sort of showcase report, which Sophie popped the link into the chat box earlier. So please do go and check that out. It delves deeper into what David talked about, were our successes and achievements. And finally, on behalf of the Earth Systems and Climate Change Hub, I would like to thank you all for attending this and other webinars and for engaging with the Hub, for participating in our research and for generally supporting us over the last 6 years. It's greatly appreciated. We simply just could not have done it without you. And we do look forward to seeing the great work of this Hub continue and be built upon in the next Climate Systems Hub. So we hope that you can engage with that Hub as well. So thank you everyone again, and goodbye. Thanks.